we have a very simple agenda for today. The first is to talk about the origin story of how auto research actually came to be. So as you guys all know that it was tweeted by Karpathy. So we'll talk a little bit about that. How does the repo look like? So we're going to go through the repo of auto research itself, top to bottom, and then we're going to have a fun demo. So I've picked out a verifiable problem from our own conference, and I'm just going to sort of give like a very small demo on how you can run it for our verifiable problems, or like how you can design auto research for our problems or any other problems which you're interested in. And then we'll dive a little bit deeper on how the community has been using auto research, and also how we at Lossfunk are using auto research. Then at the end, we're just going to have a bit of like, learnings from our some prior experiments which we ran, and like sort of like guardrails to, make auto research sort of perform better. So let's begin. The origin story. Karpathy, tweeted it out, and it got like a lot of likes. It was really, like it just boomed and was like trending and stuff. But in very simple sense, auto research is like a hill climber, which sort of tunes your hyperparameters so that you get the desired results which you want. And basically, we have the repo, and I'll open up the repo and we can discuss it in more detail there. But basically, it has a simple or like a single train.py file. So I believe this one was on NanoGPT, and it also has a single program.md file where you can, tweak that file for your desired task. And it also has something interesting like a never stop tag. So it allows these agents, like, whether it's Codex or whether it's Claude Code, run for like, run autonomously for several hours, or some people even got it running for weeks. So I just get out of the PPT. And yeah, so this is how the repo looks like for Karpathy. And as I said, they have a simple train.py file. So this is the file which the agent sort of modifies. So it can like, modifies these functions, it can modify class, it can add its own new functions and stuff like that. This prepare.py is a file which it cannot touch. This is like to set the baseline for the run or like the experiments which you want to run. And this is like, the main markdown file. So program.md. So it has like all the sort of distributed things which the agent needs to read. So you can either point it to this file, or you can copy it and paste it as a prompt. So it depends on what you want. And it has like, setup, like how the agent should, perform. So it says like, it should create a new branch. It should read the specific files, and it should have this like, results.tsv file and all that stuff. And then it tells the agent what it can do and what it cannot do. So over here, it says that, it can modify train.py file. Everything is fair game, whatever it wants to do. And then the other files, it can't, change those. And it has like more like, how does the output should look like, and how does it need to log the results. And over here, this is the, the main part, loop forever, look at the state, and then you tune it. So it works in a, like, like I said, it's a hill climber of sorts. So whenever it does an implementation, it either keeps it or discards it. So whenever it keeps it, it logs it into that file. And then based on that, it iterates further. So, and then over here, the best part, never stop, keep it going. They might be away, they might be drinking coffee, they might be even sleeping or something like that. And it's just overall very cool because it just runs autonomously, and you basically don't even have to do anything. So this is how auto research works in default. Now, how can you use auto research? Because it's such a, assuming, so like the first thing is obviously finding a task, and it can be any task. It can be our verifiable problems. It can be a task which you're interested in. I also have some examples at the end, so you guys can check those out. But so the main aim should be to find a task, and then tuning that program.md for that specific task. You can either do it manually, or you can do it with the help of another LLM. And obviously, if you have a subscription like Claude Code or Codex, pointing it at it. And if you are, sort of running very GPU heavy experiments, then you'll need obviously a GPU, and then you just run it, and then you can just walk away, go to sleep, have some lunch, stuff like that. Or since it's raining, you can have some pakoras or something. But So let's, for this demo, I've taken this problem specifically from our conference website. It's part of the verifiable problems. So this is the Hadamard maximal determinant sort of problem. And the problem details and everything is here, so I won't dive too much deeper into it. But based on, sort of structuring and what is like the record holding matrix and stuff like that, I have made this sort of, auto research, like a structure, file structure for that. So you guys can see that we have a prepare.py, which it cannot touch. This is to run the baseline. This is the train.py, which it can, sort of edit on its own. And all of this was made obviously with the help of Cloud Code. So I didn't do it personally. I just, gave Cloud Code that this is the website, sort of converted into an auto research sort of program, and you can, start experimenting. So over here, we have three sort of MD files. The main is, the program.md file, which we discussed with Karpathy's auto research repository. And this sort of has like the structuring for both the problems and what the agent can and cannot do. So very similar to that, you guys can, use this program.md. And we also have two other files. So one is a problem.md. So this problem.md is it gives more information to the agent about what the problem specifically is. And we'll talk about that a bit more in the later stages. But this problem.md file helps it understand the problem better and, run it accordingly. And then we have a prompt.md file. So this prompt.md file, you might be wondering why I made it. I mean, this was just for the sake of ease. But you can have this prompt.md file and you can point Cloud Code or Codex to that specific MD file and it can, start running. So I'll just copy this prompt right now. And as you guys can see, we have like, very similar structure. We have very similar structure to how the original program.md file looks like. So it has like, run commands, which it can run for faster iterations. So the agent has complete autonomy to decide what it actually wants to do. So we're going to run, Cloud Code, and we're going to run it in this permission mode so that it doesn't ask us for like every small thing. And it's over here. Hopefully I have enough credits and they are not, destroyed or something. But I've copied the prompt and let's just paste it. And it's just going to start running. I'm not going to need to do anything. It has started reading the specific files. Let's check it out for a little bit as it's, galloping and doing all those cool stuff. But this is very cool. It's going to start reading those files. And first, it's going to run the prepare.py file to basically run the baseline. And then I guess it ran into some errors. So it's going to fix those errors and then start running again. So let's get back to the slides. We can check on it later. So, that's how you very simply run auto research. Just find a problem you're interested in. You can either convert it to a research sort of structure, or you can give it to an LLM and ask it to convert it into that auto research structure, and just have a prompt, have the problem, and if you need GPUs, get the GPUs and start running. And it's going to run in the background. And as you guys can see, long hours of waiting. So it's I did an experiment before, and this is sort of a screenshot from our initial experiments which we did, and you can see that it was running for like 1 hour, and it was on like iteration 12 or 13, iteration 12, and it was trying something. So let's talk a bit more about how the community
sorry to cut you off, but a couple of questions before we move on to the examples. So Jack has two questions, But the two questions are, A, how much scaffolding is required to utilize this effectively? That's what Jack is asking. And he's also asking, like, how is this different from if I go to Codex and like give it a goal command and tell it to sort of, use that, So yeah, you can go ahead and like sort of answer.
Yeah, sure. Regarding the scaffolding, as you guys could see, the amount of files or like the amount of things which you require is actually very minimal. So if you can sort of convert the problem into a single eval, then it's auto researchable. That's the frame. And another thing, the second question, which was the /goal thing. I believe that they both are very similar in that state. But I guess one advantage of having auto research is just having control over certain things, and that's another experiment which we are doing internally at Lossfunk. How much can you control auto research? So slash goal, as far as I know, you just describe what you want, and it sort of does that. But with the help of auto research, you have these sort of scaffolding, like you have these MD files which sort of ground it in very different styles, and based on that, you can just sort of control where you want to point your auto research towards. And let's just say that, I mean, slash goal itself is auto research. That's what I feel. So I think they both are very similar. I think the only difference could be how controllable they both are.
I think Ajay has a great question, Abhinav. I think, and it sort of ties into the community examples that we're going to talk about, which is he's saying, given a harness, can I just point auto research to learn the goal of the harness and then do continual experiments to come up with the most optimal harness?
I mean, yeah, sure. I mean, that's another example. That's an example which we have, and it's really a great question. And I think you can do it, and I feel you should do it. And that's sort of like, recursive self-improvement, right? You're sort of giving the agent evolving abilities, and it's like, just imagine your auto research giving itself more tools so that it performs better. And I think it's a really interesting problem. And if you're able to achieve that, then who knows, you might be getting some calls from Anthropic and OpenAI.
And I mean, to give you an example, Ajay, as sort of, you can hit me up after, I'll share the paper, but I think folks in Jeff Kloon's lab have actually sort of used a similar iterative refinement hill climbing system to develop better memory architectures for their respective agents, right? So that's one example of sort of how you can improve the harness by like actually using something like auto research. And so Siddharth has a great comment, I think, that you could like sort of address again before the examples. He's saying, hey, all of these seem to be variants of the Ralph loop goal auto research. The main thing is verifiability and specifying very clear targets. Would you agree? Like, is it very similar to, let's say, the Ralph loop, like on Claude Code?
I mean, yeah, I think it's very similar. And to be honest, I do agree with that comment that just sort of, I think more interesting thing would be sort of seeing how you can use auto research on non-verifiable problems, because like I said, auto research itself is designed in such a way that if you have a single eval, then you can do it. But sort of evolving auto research for non-verifiable steps, I think, are very interesting. But I guess it is all just very clear and like, sort of constrained instructions which you're giving to the agent, and it's just following that. So think of auto research like, you setting up this background and sort of, hey, this is the steps which I need you to do. Don't deteriorate from it, but run continuously. And that's what auto research basically is. But in like the next slide, we'll talk about how you can, make auto research a bit more exciting than just like a simple Ralph loop or a simple hill climber of sorts. And I think that'll be really interesting.
Yeah, no, thanks, Abhinav. I guess we can continue. But like Abhinav said, right, like I think sort of the structure of auto research that Karpathy constructed is like just so easy to like build on top of and get started with. I think tools like Ralph loop and Goal, etc., still depend heavily on, let's say, how good the human using those tools are at, like, let's say, using tools like Claude Code and Codex, right? And there's a little bit more interaction. I think, like Abhinav earlier said, the markdown files and the structure of there being like sort of one program file and one train.py, which is being edited, it just makes it very pliable for most people to get started with this sort of iterative climbing refinement research. So yeah, that's great. We have one more question. We'll come back to it, Abhinav. You continue. Yeah.
Okay, cool. So let's talk about a bit about how the community has been using auto research. And to be honest, they've been using it in really, really interesting ways. And I think one example which I'd love to highlight upon is Hugging Face, making their own ML intern, which is built on top of like, an auto research structure. So they've basically made someone or like a tool which sort of replaces their own post-training team. And that's very funny. But another great example is OpenAI's Parameter Golf Challenge. So that challenge recently happened. And I think over there also it was really interesting because the problem itself was divided into sort of 3 sets. And you could, basically point auto research at it and get to a leaderboard. And that sort of highlights that if auto research itself is getting into the leaderboard, then it is doing some sort of hacking or some sort of tuning correctly to get to like the leaderboard. And I think that's really interesting. And they had like, and I'll talk a bit more about the metrics. The major thing about the metrics over here is that they all sort of focused on very similar metrics. So they had one singular metrics which they were measuring on. Parameter call was on BBP, and ML intern, as you guys can see, it was on GPQA accuracy. And then when we move on to the next slide, these are a bit more interesting applications of auto research. And this sort of highlights a question which someone asked. Sorry, I forgot the name, but bilevial auto research. So what this basically does is you give the agent sort of itself, and it evolves its architecture accordingly. And auto research can rewrite and improve its own search algorithm, and sort of it's self improving its architecture. And I find that really interesting. Another one which we sort of took inspiration from was the second picture over here, which is controlled experiments. So over here they're talking about if you give an LLM agent CS papers, they improve their hyperparameter search results by that like 3.2%. And you guys can see a really pretty graph which they have made, that when they gave that paper lantern paper, it was able to get better val loss. And I think the main takeaway from these two, or like these four examples over here, is how you are designing your loop. And I'd break it down into sort of three choices which you have. The first thing which I had already addressed, which is how scalar is it? So if you can't write a sort of one line eval or like a one specific eval, then you can't auto research your problem. And the second thing which is really important to think about is your experimental design. So what are the things which you are freezing? So let's say if you're freezing the model, then you are sort of studying the data. But if let's say you're freezing the data itself, then you're studying the architecture. So the frozen choice which you're making is like the sort of scientific choice. So like, this is the thing which I want to get. And then what's tunable, that's like the third thing, which is the hyperparameter search. So everything else. So, and that's where like the quote novelty lies. So how the agent sort of tunes the hyperparameters and tunes the specific, little variables and stuff. That is where like, so those three things I believe are like the three main choices which you should have when you're designing your auto research loop. So how scalar, that is, if you can write it into a one line sort of structure, then you can auto research it. If you can't, then don't. Second is what is frozen. So your experimental design. And then what's tunable. So what is the main thing you're, trying to tune and trying to get minimal or maximum of. And here comes the interesting part. How is Lossfunk, using auto research? And this is the project which I am working on. So we sort of started off with this question in mind, which was like, see if we can, sort of use neuroscience papers and see if they can act as strong idea priors for research and try to solve, sample efficiency. And I hope you guys like the figure which I've made over here. But the problem which we chose over here is BabyLM. And the reasoning for that is it's, very similar to how a human baby learns. They have a very limited vocabulary. And in that sort of limited vocabulary, they tend to learn a lot. So our question was, if we give neuroscience papers which have that, sort of human cognitive structuring in them, can those act as very strong idea priors which can be implemented into BabyLM, and see if we can sort of get a minimum val loss on that. And for this specifically, I'll talk a bit about how we changed auto research structure to support this experiment. So these are a few images, but I'll go to the GitHub repository and I'll show it in more detail. And I'll just go right now. Yeah, so over here you guys can see that we have this is the auto research sort of file, and we have three separate or like two separate program.md files. And because we were testing, vanilla arm, that is just pure normal ML or like a pure normal auto research with no priors or anything. And another one was with the help of these neuroscience papers which we had collected with the help of XI API and Semantic Scholar. So you guys can see that this is the one which I want to focus more on, because this is the neuroscience part. this is this it has a very similar structure to the actual program.md file, and the major thing to focus over here is additional neuroscience guidelines which we give to the agent. So this all these sort of points were made from prior smoke tests and smoke results which we did. So like very small iterations. So we said that it should prefer sort of zero parameter or low parameter changes because they tend to be less confounded, and avoid repeating known failed families unless a paper provides a new mechanism. And this was done with the help of prior results. So this is another thing which we found, that if you give prior results, so like that is memory basically, it tends to experiment more. And we had this translation guide which we built, or like which we wrote based on prior results. So the core principle was, don't translate the biology literally, try to translate the computational principle. Like I said, lots of ML transfers were based on very loose neuroscience inspiration. So your CNNs were based on visual cortexes, and your delta net attention is based on delta rule error correction and stuff like that. And we had a few more instructions which we gave to the agent so that it was more grounded. So like what are good translation patterns. So try to identify the computational role which is actually important. So if you were to implement this, would it actually improve and stuff like that? Throw away details which don't matter. And again, like I mentioned, prefer changes that cannot be explained by capacity, which is like a control which we had. And we had more examples of what are bad translations. So basically we made this file from our prior results which we got, and this translation guide helped the agent get better sort of ideas. And over here you guys can see we have a sort of task.md file. So this is basically similar to how our this one is, this problem. So it sort of gives a lot of detail on what the benchmark actually is, which is BabyLM, and what's the research question which we're targeting, what does improvement mean. So the agent sort of knows what it needs to target. And then we have this all the similar stuff. So these are the program.md files, prior results, and it was very cool. And based on this, we got interesting results. And you guys can see over here, really nice graph. You can see that the neuro arm actually ran for less turns. So the amount of experiments which it did was quite less. But the val loss over here, which it achieved, was way better than vanilla arm. And this is the accumulation of 3 seeded results. So 3 runs, and then based on that, which was the best one. So we have chosen the best of the 3. And you guys can see that the vanilla arm ran for almost 52, 53 around experiments, and it still could not reach the val loss which neuro arm sort of achieved. And before I move on to the learnings, let's just check on our run which we had, and we can sort of take a few more questions if there are any. So
there's a bunch, Abhinav. So yeah, so let's look at the run and then we come to it.
Yeah. Okay. So it seems that, yeah, you guys can see that it's making lots of huge changes, and I guess it ran into some errors. Best previous run achieved was a ratio of 9262. It got this sort of determinant, still short of the record. So let's see if by the end of this run, if we beat the record itself. At the end of this presentation, if we have beaten this record, then I think I will also submit.
We would have solved one part of submission is one thing, but we would have solved an open problem.
Yeah.
Yeah. But please submit. Yeah.
Yeah. So what are the questions? Can you?
So I think, Jack has one on aha moments. I think we'll sort of, cover that in the learning. I think you can talk about that. Right. The interesting question, I think, for me would be, hey, do you think this sort of forces the LLM to hack the test in some sense? Doesn't this lead to hallucinations and where it would just do something random, try to maximize the metric as opposed to actually stay grounded in what we need to do?
Yeah, to be honest, that's a great question. And I do agree. They do tend to, reward hack, because auto research itself is based on that, 5 minutes training loop. So it needs to sort of tune the hyperparameters which don't go over that 5 minutes training loop. Now, obviously, you can change this and give the agent sort of freedom to run forever. But then it might start implementing things which take 5 days, and we don't want that. So I guess the main real use case would be sort of finding the right balance. How long do you want that train.py to run? But I do agree that a lot of these interventions, like over here, also I have an example in the next slide. But yeah, they do reward hack, and since they are hyperparameter tuning, they will definitely reward hack. And what's the next question?
Yeah, no, that's great. Right. I think, but I would imagine that the train.py sort of like the fact that you're actually running the training at least grounds it from hallucinating something that won't run, which could be commonplace in, like, let's say, a non-auto research type infrastructure. It reduces the sort of solution space and it sort of reward hacks that way.
Like based on the first and second, like previous iterations, since it builds upon iterations, so it could, like, try specific tweaks, and one tweak could not work. And since you have that upper limit of 5 minutes, it is anyway going to try the tweak whether it's 5 minutes or not. But that sort of 5 minute thing does sort of limit its idea space, and we'll talk about that more. But I don't think it leads to hallucinations in like the typical sense. I think the reward hacking state, or like the reward hacking phenomena, is, I agree with it. I would not even try to disagree. But the hallucinations thing, I don't know how that could be achieved. Maybe for tougher problems where it's not trained upon, it could hallucinate things and not do great at them.
Yeah, no, that's great. Thank you. And like, so one last question before we jump into, let's say, our learnings and takeaways, right? And you can combine these, right? So one is sort of around running this in the context of like local LLMs, which have finite context and there's no auto compaction, etc. So like, have you thought about mechanisms for checkpointing in that case, etc.? And sort of an extension to this in some sense is, how do you, let's say, A/B test different program files, or how do you test how efficient your auto research setup is, right? I think you've iterated upon your program file a couple of times now, right? So would love to like sort of hear that as well. So memory, like in case of local LLMs and checkpoints, and then how do you measure the efficacy of the auto research setup itself?
Yeah, cool. So the first question, which is memory itself, I mean, to be honest, I've not tried it yet with local LLMs. That is one thing which I do want to try. And again, if you have the GPU, please give them to me so that I can do it with local LLMs. But I do think that without the sort of harness which Claude Code or Open Code or Codex or even Pi.agent, whatever these guys are giving, if those are not present, then I think it does sort of become hard, because once it hits the context limit, it can't sort of proceed. And that sort of compaction thing is what helps it a lot. So I think it would be really interesting to try with local LLMs and sort of like making our own harness, or trying it with Pi.agent or something like that, and removing the compaction tool and see how does performance degrade or maybe improve in that. My hypothesis is that it will struggle a lot, and this compaction helps it a lot. And the second question, A/B testing, I think I'll be very honest. The how I iterated upon these program.md files was purely based on vibes. So, but if you do want like a sort of concrete metric, I think you can get a good gist of how it performed in like one run. And then let's say you made some tweaks on that, and then you ran it again. So I would suggest time boxing them. So like, maybe 10-minute runs instead of like, an hour or something. 10 minutes runs, how well did it do with one prompt? And then when you, or like with one program.md, and then when you change the program.md, how well did it do then? If you see a sort of like, difference in its, when you're like checking its reasoning and stuff, if you see a sort of difference in its idea space or search space and stuff, then I think that's a good check mark for you that this program.md works. But I believe that proper like software engineering sort of A/B testing is very hard, because these systems themselves are black boxes. So there might be one chance that with that same iteration, same program.md, it might outperform the improved program.md. But I think you can iterate upon it based on the results and sort of your vibes. So yeah.
Yeah, no, that's great. And I think, I mean, this was a question from Alok, which is, in some sense, Alok, this is like sort of a plug-in for your own work around the benchmark on novelty, right? Like, so I can imagine you can totally, like Abhinav said, if you sort of time box the runs, you could probably build a rubric to judge like sort of the reasoning or like the entire trajectory, and then feed that rubric back into like sort of your program.md file, right? And as like, but like Abhinav said, right, like this is it's not going to be 100% perfect, and B, it will still come down to sort of the rubric building will still be vibes in the sense that what do you expect out of like those search trajectories, and how do you want to push the base LLM in whatever directions you prefer to go on your scientific project or on your research project, right? So yeah, like that would be the answer.
So learnings over here, I have a good example as well. So the first thing is that the conceptual understanding is really great, but when it comes to code translation, it's not that strong. And I think a lot of people also have reported these sort of failure modes with AI scientist concepts as well, that they are able to. I'll give a specific example that it was able to understand how to, or it was able to understand the neuroscience principle and the idea behind it, and it talked about how it could be implemented really well when it was reasoning, that is Claude Code was reasoning. But when it actually had to write the code, it sort of fell into a template structure. And when it does sort of implement that, and you ask it to defend that implementation or translation, it defends it with like a really confident story, and you guys can see the example over there. So it implemented something which it titled as anti-collapse norm. And now when you guys hear it, it might be like, oh my God, what the hell is this? But, and it, it gave this reasoning that I, took these two papers and took specific things from them. And it really hilariously says was my creative translation of the principle, which I found really funny. But once you, dive deeper into what this anti-collapse norm thing is, it's just a post norm with a variable clip. And I was able to catch it with the help of a fellow researcher who sort of looked at the implementation. So like a human judge looked at the implementation and said that, hey, this is just, post norm with a variable clip. And I think that's where these, systems, that is the one learning which I have, that they sort of exaggerate what they have implemented. So having a sort of rigor behind you, or like having a sort of grounding, like, are you sure this is the right implementation? Are you not just, and even in this example, when I asked it, why is it not post norm, it just gave something very similar to this. Another thing is, ideas fall into a local minimum. And by this, I mean, like over there, I have an example. So we tested 100 ideas. So what we did was we took autoresearch, that is Claude Code, and we just gave it a prompt that even before implementation, list out 100 ideas which you would like to implement or try out for this specific problem space. And we did it 3 times, same prompt 3 times, say no memory, nothing, and we got like the same list for all those 100 ideas. So it like said, I'll first try post norm, then I'll try FP8, I'll try BF16, or like similar sort of structuring, like optimization structure. And in those 3 iterations, the lists were like slightly shuffled. So maybe like BF16 was not in 2nd place, it was in like 5th place, but it just sort of gives an idea of a latent laundry list which it has. Like I have to do this, I have to do that, sort of like a checklist which it's checking off. And so the ideas which it tries is very limited, and they sort of fall into like a local minimum. And we can talk a bit more about how you can solve this. Obviously papers are great, and there are other ways you can do it as well. Another thing was, which we found, was testing these, neuroscience priors ideas on BabyLM itself was maybe not the greatest choice, because BabyLM is a pure text-based benchmark. And since neuroscience has a lot of multimodal ideas with like, visual and auditory and all that stuff. So maybe a sort of multimodal like benchmark, like, RKGI would have been a better sort of testing ground for this. And that is something which we are trying. So if we talk about, what are the tips which I would recommend from my learnings for your next auto research run, is I think a task.md goes a long way. So that problem.md, task.md, which sort of details out your task or problem in, I mean, like in much more detail. It provides the agent context much better. and it's able to ground its implementation really well with the help of that task.md. And let's say if you're like trying out different ideas like we did with neuroscience and vanilla, having different program.md files also help auto research sort of ground I mean, it helps you ground auto research in different sort of idea search spaces. And another thing which we found was having this sort of verifiable or like verifier in loop or adding these checkpoints before implementation. So like I talked about here, the ideas are falling into local minimum. This was a sort of checkpoint which we had. Another thing is like, giving it pseudocode. So before it even implements the code, having a sort of check, like write the pseudocode down and then verify it with like a different LLM or something like that. Or asking the agent, is this implementation actually necessary for the problem? So one example from this, from our previous runs, was it implemented something related to catastrophic forgetting for BabyLM. But if you think about it, it's just 100 million words. There is not going to be any sort of forgetting at 100 million word stage. So it implemented that because it was a neuroscience idea and it didn't think about, is it actually useful for the problem? And that's where we lead on to adding a creative anchor. And that's why what I mean by adding a creative anchor is that it should be humans x auto research. These are two really one blog was shared to me by Dhruv himself, and they talk about how models are really good at well-scoped problems. So like BabyLM is like optimization problem, and so this is like learning from optimization arena, and they basically say that they're really good at well-established problems, but when you give it sort of these new problems, they tend to struggle. And this is a really nice paper. You guys should read it. And they basically talk about human creativity tests and seeing if these human creativity tests can be used for large language models. And they're testing whether this, are they a good predictor of how creative large language models are. And that's what I sort of mean by having a creative anchor, because these agents are, or like these, this auto research is very limited in what it can do just alone, or with the help of like web search. Grounding it in like your own research taste or your own sort of implementation and ideas sort of gives it a grounding or like sort of a path which it can take. And I think that's really interesting. So at the end, is auto research actually automated science? Not really. I'll say, in like if you had to ask one single line for me, it automates the hand, not the mind. And I'm really proud of this sentence. Even Dhruv loves this sentence. And what I mean by this is that good science overall focuses on three questions. One is, what are the questions which are sort of worth asking? And that's what we mean by, research taste. Like, is this question actually helpful or is this surprising? Second is generating new hypotheses. And third is producing an understanding of why something isn't true. So auto research over here just outsources the first part, which is deciding what questions are worth asking, to you. Like, you are the one who's deciding what task it should do, what sort of structuring it should follow, and stuff like that. It links to with the task. So that is generating new hypothesis itself is the hyperparameter tuning, which it does with the train.py file. And then producing understanding of why something isn't true, it just discards it. It doesn't even care because it's not programmed for that. It's just, you're just asking it to be an engineer. And that's why I say, or I mean, engineer like is just gonna do tweaks. So that's why I say it's automating the hands and not the mind. And I think this sort of answers one question which a person had in the chat, that we might be getting lazy with these agentic tools and stuff. And I don't agree with that completely. That I think these tools are really great at implementing your ideas, but you're the one who is giving the ideas themselves. And just a bit more about our, confidence.
I mean, actually, before we get into this, right, like,
Yeah.
for the sake of like, sort of like, I think there are two questions I think which would be interesting to take right about now. Right. So one is, hey, somebody asked, which is like, are you only trying to like sort of maximize or minimize something here, right, without actually caring about how it got there? Like, or do you sort of think about building guardrails in the reasoning and like in the implementation to verify the steps that it takes to get to that, like, right, specifically with reference to, let's say, your experiments on it?
I mean, for us in our prior experiments, which we did, we mainly just cared about how we didn't care about how it's getting there. We just cared about the results. Our intuition was that if it is, improving, then that means that that sort of implementation is working, right? And that was our intuition. But I do agree with the point of having a sort of structure in the reasoning, and that's what I meant by, asking or giving the agent sort of a self-check loop where it asks itself that is this implementation actually necessary, is very important. So I'll be very honest. The prior runs which we did just cared about the val loss which we were getting. Now the upgraded question cares a bit more about, are these auto research components, or like is auto research itself controllable? And we're like, trying a lot of different ideas from that.
Yeah, that's great. Thanks, Abhinav. Right. So, I mean, just to reiterate, right, like, I think you have to understand that I think with most of LLM systems, they're not, fixed, right? Like, you can, like, sort of update them in ways that you want them to be updated, right? And there's no one right way to build any of these systems anyway, because the LLMs themselves are, like, incredibly stochastic, right? So that said, I think last question, and then I think we can talk, like, perhaps look at the run and talk about the conference, right? Which is a general question from Viswa, and it was also, like, plus by Jack, which is like, would you recommend that this is useful for problems you know how to solve, and it's taking too long to solve, so you automate it via auto research? Or do we also use it for problems we don't know how to solve and let the LLM figure out without control on how it solves it?
I mean, like the run which we have is a sort of open problem, and I'll be very honest, I don't know how to solve it. So right now I've just let auto do it for me, or like auto research do it for me. And I think it's very interesting to give these auto research agents or like run them on unknown questions, or like questions which you don't know how to answer, because there's a chance that you might find something which is actually interesting, and you can build upon that further with your own intuition. So I'll definitely recommend trying it on unknown problems. But I do believe that you should maybe either consult with another, like, you should either be an expert in that topic slightly, or consult another expert who is in that topic, or consult another LLM. So, like I said, for that anti-collapse norm thing, I had to ask one of our fellow researchers here at Lossfunk, Ayush, that is it actually, like, very exciting? And he just said that it's a post norm with a variable clip. It's just exaggerating by calling it anti-collapse norm, like it's some great phenomena. So yeah, I think that you should run it on unknown problems, but then check whether is it actually a great implementation or whether it's a reward hack solution. My hypothesis is that it will lean slightly towards a reward hack solution, but there is a slight chance that it might give you a very novel solution.
Yeah, no, that's great. And I think, like, a great place to plug in the classic AI/ML text, the bitter lesson, right? Like, and I think, we got to, like, embrace that mindset as we do science in the future, which is, it's good to move the onus to verification if that must be the case, right? Because there are, like, problems that can be solved in various ways, by scaling up, like, the number of attempts, and that works better in some cases than, let's say, sitting linearly and, like, thinking through it, which might take ages, right? So yeah, that's great. I think there's one last question from Akash. I think he's asking about a specific problem. He's saying he has a highly complex curve using the minimum number of sample points. Can such a system help determine which metrics or criteria should be used to achieve the best fit?
I just read the question.
Yeah.
It's the most latest question, right?
Yeah.
I mean, I do think that you can use it. Ultimately, like, like I was not able to get the full context of the problem over here, but I think it's worth a shot. And I'm not sure what sort of data or inputs you would need, because I don't have a very clear idea of what the problem itself is. So I can't give a lot of details on what sort of inputs you would need. But I think it is sort of implementable and auto-researchable. I think if you want a term for that, if you're able to, like I said, if you're able to get it into a sort of single metric, which or like a single problem, which you want to sort of tune and all, then yeah, sure, go ahead. You can auto-research it, and maybe it'll find something very unique, which even you didn't know about. But again, ensure you verify the solution as well.
Yeah. Yeah, and I think, like from my understanding of the problem, like Akash, I think it should definitely be able to do it, right? Like I think the interesting thing will be how you sort of set up the program.md and task.md, etc., right? Because you're trying to find out a metric here, right? So then the metric that auto research is hill climbing on is the success of the metric that it's sort of come up with. Like it's a little meta, right? Like so you'll, like Alok said earlier in the chat, a good place to start would be to take the auto research repo or the Evo Scientist repo, and just put it into Claude and be like, hey, this is the problem I have, and I want to bring it to a structure that we can use. And I'm sure it'll do a good enough job. Happy to brainstorm. Last question, Abhinav, I think, from Jack, since we missed it, and I think it's a good note to sort of move to the conference also, is any aha moment for you when you tried it, right? Like what all out of the box things it achieved that a human can't in limited time? I mean, all of this seems to be like something that a human can't do in limited time, but yeah, what was your aha moment? Yeah.
I mean, in terms of aha moments, I define it very differently. Like aha moment, I guess over here would be a sort of negative thing for me. Like if you just go back a few slides, where is it? Yeah, this one. Like the way it sort of adamantly supports or like grounds its implementation is sort of very concerning, or like very interesting, because after I even gave it proof that it is a post norm with a variable clip, it's like, yeah, you could say that, but I believe that it is more anti-collage because it has XYZ things. And it would just, sort of give reasoning which didn't make sense. And I guess the major aha moments is going to come from the questions which we have, which we are doing right now, which we are implementing at Lossfunk itself. So a bit of like, teaser at that is the one thing which I talked about, which is ideas fall into a local minimum. I think that was very interesting. And another thing which we tried was having same prompt run 5 times and then having that prompt rephrased slightly and running it 5 times. And for different problems, that is different benchmarks, it sort of did worse, did the same, or did better. And so that sort of gives a structure or like a controllable lever, that a prompt is a controllable lever for specific problems. So how you write your prompts are also really important. And I guess that would be like, 2 aha moments. One is like, just to summarize, one is like how it adamantly, says that, hey, I did this implementation, it's correct, it's not this. And second is sort of having these controllable levers, which you can use to sort of improve your auto research itself, auto research experience, I'd say.
Oh, that's great. Thanks, Abhinav. And like, I mean, I just like, we'll take more questions, folks. Like, I think, we can stay behind 5-10 minutes, but I did want to wrap up, right? And I mean, to the aha moment question, Jack, I mean, I hear you, like, get a sense of the skepticism around like sort of LLM sites, right? But I must say that just even conceiving of a project like this, right, where you have like a large library of neuroscience papers that you can like sort of readily adapt to ML problems, like would be incredibly hard to do in the absence of like LLM systems in general, but specifically like an iterative refinement system like auto research, because neuroscientists don't talk to ML scientists. Like that intersection is very, very small, and the amount of like sort of brain working cognitive bandwidth that would go into adapting neuroscience insight to ML and then testing it on a task and coming back, that easily is like at least 10 days worth of work for one paper, right? And here we sort of already at the scale where we're like actually judging like a large pool of papers and allowing those implementations to scale up. So I think that in itself, like, I mean, I know Abhinav is like grounded in the experiments, so he gave you like more legit aha moments. Like, but for me, like as somebody who's outside of the project, right, even the mere framing of the project itself is sort of like a aha moment, which would not have been possible, let's say, like even 6 months ago, perhaps, like, or, like 2 years ago for sure, like, it wouldn't have been possible, right? So yeah, that's a little bit. super quickly, like as we're wrapping up last minute, right? Like I still want to like just sort of, re-emphasize that we're hosting this conference for AI scientists, right? Like the idea here is to use LLMs to do science. Auto research is just one of many ways that you can use LLMs to do science. You could just be doing a co-scientist, human in the loop workflow. And that also counts as a valid submission. It could literally be just using LLMs at the manuscript creation stage, right? And that would also count as a valid submission. The amount of AI use is not an eligibility criteria, but we request everybody to declare it as a part of AI involvement checklist, which is a part of the submission template. But yeah, like I was saying, we have over $20,000 of awards. We have a great program and steering committee, and we also are prepping like a wonderful online two-day online conference where you guys get to present your work on the 24th and 25th of July. We'll be probing further these themes of AI done science in the future. So yeah, please do like sort of, check out the conference and submit. The deadline is the 30th of May AOE, which makes it 31st of May, 5:30-ish IST. And yes, Jack, even if you don't participate in the form of a submission, you can still attend. But I would still encourage you just from this session that you take your ML repo that you had and try to do a submission. Even just the experience would be like incredibly insightful, and we'd be happy to like sort of, have reviews sent back to you regardless of what the acceptance output is. Right. So yeah, please do like check out the conference. Right.
One more thing which I'd say is, since these auto research systems are so like for me personally, I find them really uncreative when they are not, sort of grounded in structures. So maybe we can, point, if you guys want some more interesting questions, you can, try it on these sort of questions. Obviously, we have our own verifiable problems at our own website, but we also have a lot of more interesting questions, which I think would be really interesting to do. One is obviously, GPU kernel optimization, which I think a lot of people are focusing on right now. I think another really interesting problem is auto research in the search mechanism itself. So that is the same, sort of structure as bilevel auto research. Seeing like, can you give auto research or can you make auto research sort of make its own tools, and it uses those tools to make, further tools, and, it goes into like a recursive self-improvement. So you guys can, if you want, you can take a screenshot of this slide. We'll also share the slides so you guys can check it out later as well. And with that, I'll stop, sharing my screen, and we can have more questions which we can talk about.